It's your friendly math tutor, Miss C, here to simplify exponential expressions using multiple properties. The big idea today is that we are going to simplify as much as we can in the in the parentheses before applying that outside exponent. So let's go ahead and get started on that. So sometimes I suggest to students that they might want to color code the variables that are the same. So I've done that for us here. You can see that we have m's in the numerator and denominator, and we have t's in the numerator and denominator. And then a and variable h are on their own. So let's go ahead and start simplifying inside the parentheses. So 3 stays the same, and I'm just going to simplify the variables we have in common. So those that are color-coded yellow and purple. So I have m to the negative 2 divided by m. That rule is the power or the quotient of a power property. That means we subtract the exponents. And you might remember that there's a secret 1 on this m that we don't write. So it's negative 2 minus 1, which is to the power of negative 3, because I'm writing that in the numerator. And then we have in the denominator 2 and a to the 4th. I'm kind of going in order here. Then my t's, t to the 9th divided by t to the 8th. That's still the quotient of a power property. We subtract those exponents and we end up with 9 minus 8 is 1. So just a t, but we know there's a power of 1 there. And then h to the negative 1 stays the same, and all of that is raised to the power of 5. All right, now that we have everything simplified in the parentheses, let's go ahead and apply our our outside exponent. That would be this 5. And remember, this is the power on power property. That means that we multiply that 5 by every exponent we see to get our new exponent. And I went ahead and put 1s on the coefficients and the variables that don't have exponents written. So I'm going to go ahead and I'm going to rewrite that over here. So we end up with 3 to the power of 1 times 5, which is 5. M to the power of negative 3 times 5, which is negative 15. T to the power of 1 times 5, which is t to the 5th. 2 to the power of 5. I'm doing the exact same thing. A to the power of 20, I'm just multiplying the exponents. And then h to the power of 5, negative 5. All right, so this is technically correct, but most math textbooks would want you to write your answer with positive exponents. And we have 2 bases in exponents, the m's and the h's, that have negative exponents. So we're going to turn those positive. The other thing we're going to do is expand out our coefficients, because these both are relatively small numbers. So we're going to go ahead and expand those, and then we will have a final solution. So 3 to the 5th is 243. That's 3 multiplied by itself 5 times. And 2 to the 5th is 32. That's 2 multiplied by itself 5 times. In the numerator, I have m to the power of negative 15. If you remember, to change a negative exponent to a positive, you have to change the base's location in the fraction. So that means that since m is in the numerator, it drops to the denominator, and it becomes m to the 15th. If you need more instruction on this, I have a video dedicated to negative exponents, so go ahead and check that out. And left in the numerator is t to the 5th, so that just stays t to the 5th. We've already expanded out 2 to the 5th. And we have a to the 20th that gets to stay in the denominator because it's positive. And then we have h to the negative 5. So we're going to go ahead and we're going to change its location from the denominator to the numerator. And when we do that, that negative exponent becomes positive. All right, this is the simplified exponential expression. Let's go ahead and try another problem. This one's a little more complex. Same idea. We're going to deal with what's inside of the parentheses first. And then we have an additional step because we have 2 fractions multiplied by each other, both of which are raised to different powers. So I'm going to start again by color coding the variables that I have in common, so you can see that. And we're going to go ahead and I'm going to start with the first fraction. We have 3, and then I'm really just doing this power on power property again. I'm not doing the power on power property again. I'm going to simplify what's inside the parentheses first. So I have 3, and then a to the 7th divided by a to the 4th becomes a to the 3rd. Remember, we subtract those exponents. We have 4 in the denominator, and the n is only in the denominator, so we'll write it there. And then we have t's, t to the 9th divided by t to the 10th. Remember, we subtract those exponents and end up with a -1 on that t. And this thing is entirely squared. And it's not a thing, it's a fraction. Should be more precise with my language. All right, in our next fraction, I can see that I only have an n in the numerator, so that is fine. And then the t is in the numerator and denominator, so we have t to the 4th divided by t, which is technically t to the 1. I subtract those exponents and I get t cubed. And then in the denominator, I have 2a because a is only present in the denominator, and this entire fraction is raised to the power of 3. So now my next step is to apply the power of 2 to the first fraction and the power of 3 to the second fraction. As a reminder, all of these coefficients and variables that don't have an exponent technically do, and it's 1. Now we're going to apply the power of power property. That means I multiply the exponents by 2 in the first fraction to get the new exponent. So in this case, it's 3 to the power of 1 times 2, which is 2, a to the power of 3 times 2, which is 6, and t to the power of -1 times 2, which is -2, all over 4 squared times n squared using the same process. In the next fraction, it's to the power of 3, so I'm going to do the exact same process again with the power on power. I end up with n to the 6th and t to the 9th, 2 cubed times a cubed. And now I am going to simplify. Now, these are two fractions multiplied together, so this is a product of a power rule that we are going to apply as we combine things. So I'm just going to go ahead and merge everything together in the numerator, then merge everything together in the denominator, and then we will simplify. So in the first fraction, I have 3 squared, which is 9. I don't see any other a's. I'm going to change my color here. I don't see any other a's in the numerator, so this is going to stay a to the 6th. I have t to the -2 power times t to the 9th. This product of a power property says that we add our exponents when we're multiplying, so that becomes t to the 7th because -2 plus 9 is 7. And then we have an n just hanging out by itself. There's nothing to combine. In the denominator, we have 4 squared, which is 16. We also have a 2 cubed, which is 8. So I'm going to just write those next to each other to keep this nice and clean. And then we don't have anything else that can be combined using that power of a product property. We have a cubed and n squared. All right, so we're getting there, and I'm running out of room, so I'm going to try to do this the best that I can. Okay, so we're in the final stages. So we are going to combine our common variables. So in the numerator, we still have 9. We have a to the 6th divided by a cubed. Remember, this is the quotient of a product property. We subtract those exponents and get a to the 3rd. I do not see a t in the denominator, so t is on its own, so it stays t to the 7th. And then we have n to the 6th divided by n squared, which gives us n to the 4th. We're just subtracting those. And then in the denominator, all that's left is 16 times 8, which is, what is 16 times 8? 128. Yes, 128. All right, and this is completely simplified. And that is how you simplify, I would say, pretty complicated exponential expressions that require the use of multiple properties. Make sure to subscribe for more videos. Till next time, remember, you've got this.